Okay, so today we're going to talk about circles and radians and try to understand the geometry, especially of circles. So, our goals today is the main goal is to understand where the area and circumference formulas come from for circles. So, I want you to know the area formula for a circle is pi r squared, and I want you to know where that came from. The circumference formula is 2 pi r, and I want you to understand especially where pi is popping into these formulas and where these come from. Okay, to do that, we need to understand what a radian is, which is a different sort of measure than a degree. So for example, here you see this circle, and you on this circle I have kind of a 90-degree angle marked, and so we might call this 90 degrees, right? But there's another unit of measure called the radian. So this unit of measure is degrees, and it measures this angle, right? There's another unit of measure for angles, and that's called radians. And if you ever took trig, you used radians. And if you ever took trig, which might not be all of you, but like you know that this is pi over 2 radians, right? That's an angle of pi over 2 radians. So 90 degrees and pi over 2 are the exact same measurement, right? This is a right angle, but they're in two different units of measure. In the same way that 1 foot equals 12 inches, right? Even though those are two different numbers, we know that those are the same. 90 degrees is the same thing as pi over 2 radians. Okay, so that's the second goal. And then the third goal is to understand how to go back and forth between these two units of measure so that we can work problems. So those are the three things we're going to try and do today. Okay, so the first thing that we want to do is understand radians. And so we're going to do an activity here today to try and do that. And for the activity, you need a few things. So I have here, let's say, this is the activity we did before all of this happened. So I don't want you to think I'm doing crazy stuff. I have a can here that has a circular cross section. So I need a can. It should have the same cross section all the way down. And you have to be careful. There are some cans with this. Do you see this rounded edge there? So try, if you have one of these, you can just use the top edge. We want to use kind of the true diameter. And then I have a ruler. I'm going to need that. I also have, let me see, this is a piece of cardstock, but you need a 90-degree angle. So you can use a piece of paper, we'll just be careful with it, but you need a 90-degree angle to use. And then you need some sort of, I have this ribbon here, we need some sort of string. So you can use whatever you have in the house. You don't have to, please don't go buy something, but like if you have yarn or any sort of thing that could be used like this, then that should work fine. So we're going to do this, and you do need to be able to kind of tie this. We're going to tie this around the can, so you can't kind of use something that's untieable, but and I'm going to make some markings on it, but if you can make markings on in some other way, then that's fine. Okay. So the first thing I'm going to do, I'm going to put this camera here so you can see. And the first thing, this will be hard to see originally when I trace, but then I think it will work better. You're just going to trace around the outside of this can. So I'm going to do that. And we just do that to get kind of a circle. So you'll see there. Oh, look. Okay. So once you do that, we need to find the radius of the circle and see how big it is. Now, that's actually more complicated than it sounds because I have no idea where the center of this circle is, right? So I need to find the center. Really, the next few things are finding the center of the circle. So then I eventually can measure the distance from the center to the outside of the circle and find the radius. But the first thing, like the center is somewhere in here, but like if I just guess, it will be closer, so it's harder to find the center. Okay, so I'm using the converse of the Thales theorem. And the Thales theorem says that if a right triangle is inscribed in a circle, its hypotenuse is a diameter of the circle. Okay? So I'm going to use, that's what this right angle thing is for. An inscribed right triangle looks like this. So inscribed shapes have one corner, have all three corners just inside the circle. So this is going to be the right angle. And then here where it intersects, do you see that? So here's this right angle. I'm going to mark it right there. Here where it intersects the circle, and here where it intersects the circle, from this point to this point, that's the hypotenuse of the right angle. So, because do you see that's across from the right angle, the right triangle. So I'm going to take this off, and then I'm just going to use my, let's see, I'm going to use my ruler and connect these two other lines that I just drew. Right? Okay. So there is a diameter of my circle. Okay? So now again, that still doesn't tell me where the radius is or where the center is because I don't know kind of where it is along this line. It gives me a better idea. For sure the center is somewhere along this line. And maybe it's somewhere around here, but there's a lot of variability in what you pick. And let me tell you, it's hard to pick the center. So we're just going to draw a second diameter. And we're going to, and then where those two diameters intersect, that will be the center. Okay, so I'm going to draw a second diameter. Let me just turn, you just got to kind of turn the circle. Sometimes it helps to put it right here on one of these places on the hypotenuse because then for sure your other diameter doesn't kind of line up. So I'm going to put it there and then I'm going to mark a second time. Okay. So do you see that? I'm making this inscribed triangle. I need to put the right angle here. And then here, where these two cross marks are, I'm going to connect them with a ruler. Just like this. And abracadabra, there where these two intersect should be the center of the circle. Now, this always has human measurement in it, and there's some error in what I have done, but it gets much closer than kind of guessing. Okay. And if you look at it and you say, oh, that's definitely not the center of the circle, just start again and try it again with, you know, I've done this activity several times, so mine looks close to the middle, but, you know, if you need to start over, no problem. Okay, so we did that. Okay, so now I'm going to take my ruler and measure the diameter of the circle. Now, depending on how big your circle is, you should choose a unit of measure. So my circle is not that big, so I'm going to use centimeters. And that might be true for most of you if you're using a can. If you have a much bigger circle, you can use inches, but this has a lot more variability in it. So I'm going to use this, and I'm going to measure both these diameters. So let me see. And I'm going to line this up. Do you see my this ruler doesn't start right at the beginning, so I want to make sure. And then I'm going to come here, and I think I'm going to show you it's about 10, 11. I'm going to say it's 10.2 centimeters. That one is. Okay. And then this is another way, because to see if you're if you're on the right track, because if your measurements are way off, then that kind of gives you something. Like if I get 10.2 and 10.6, then like you should redraw that circle. Okay, so I'm here, and again, it's around 10.2. And that's good. Centimeters. Is this okay? Okay. So that is, so let me look over here. So that's the diameter, because the diameter goes all the way across my circle, which means from here to the center should be the radius, right? So those are 2, and I'm going to just measure it to be sure, but that should be 5.1. That is close. That one really looks like 5.2. And that looks more like 5. So you can kind of see even in here where, like, when you do this, they will be a little bit off. If they're, like, now that one of them's 5.2 and one of them's 5, I'm not really going to redo this whole thing. But just so that you kind of know what appropriate variability is. If they, let me put centimeters. If they were way further off than that, I would try and redo it. Okay. So I found the radius of the circle. Okay. So all of this, again, I just want to review because this is kind of a long object. The goal is for us to understand radians. And then, and to figure out what they mean for circles. To do that, radians are intricately connected to the radius of the circle, so I had to find the radius of the circle. And you might have guessed that radians were connected to radius because they both have that same beginning, same root of their word. Okay, so now I am going to, this is where my ribbon comes in, because circles, right, like have a unit of measure, like circumference goes around, but it's not a line. Like with rectangles, it's curved. So I need some sort of object so I can go kind of around the outside of this circle. And really what I'm going to do is I'm going to make a radian ruler, right? So first of all, not at the very beginning of my, so I don't want to start this, I don't want to line this up like this, because that's going to be rough. I'm going to make a beginning of my radian ruler, maybe somewhere down here so I can tie this somewhere. Okay, so I'm going to do that, and where I had a Sharpie marker to mark on here. Oh, good. Okay, so I found it. So I'm going to kind of line this up, and this is also a place where, like, if you have a stretchy piece of yarn, you kind of have to be sure that you're stretching it the same amount. But okay, so I'm going to try this. I'm going to mark this right here, and then I'm going to mark to the radius. Okay, and then I'm going to keep going. So this is 1 radius. This is 5.1 centimeters, right? Or 1 radius. Okay, I'm going to do it again. Mark it, lay it flat. Y'all are much more perfectionistic than I am, so there's another 5.1. I'm going to do this again. .1. I'm just going to keep going because I want this to go all the way around my circle. And this is what I call a radius ruler. All of these 5.1s. Let me see, how many do I have? 1, 2, 3, 4. Let's do a couple more. You need at least 7 or 8 of these. Like kind of chunks. There's another radius ruler. Another one radius. There's another one. Okay, so now I have this radius ruler, right? And really, if I was counting, this would be, the beginning is 0 radiuses, and then here's 1, right? And here's 2. The next one is 3, right? Do you see this? In this unit of measure, these kind of like non-standard unit of measure, 4, 5, 6, 7, 8. Okay. Now, let me, I need to go get some scissors and cut this up. Okay. So I'm going to just cut this somewhere after kind of my last marking. I'm going to leave some space. And then the goal is to turn this linear measure, right? This is kind of a ruler, a radius ruler, into a curved ruler around my can. So you need your can again, like this. And I'm just going to wrap this around the can. And somewhere over here where my ruler is, I'm going to make sure that, so here's the start of my ruler. So I want to tie it somewhere after the start of my ruler. So I'm going to tie it somewhere in here. And there I am. And I'm going to try and make it tight so I can make some observations about this. So, and if we were in class, I would have y'all hold like this, but we're not in class. So if you have a friend, maybe sister, brother, mother, roommate, dog, cat who can do this for you, try and do that. I'm going to try and get it as tight as I can. Okay, it's a little loose, but we're going to do this. Okay, so once you get your radius ruler around the circle that you started with, we're going to figure out how long it was. So I don't know if y'all see this. Oh, this is almost perfect. Look, I have this starting point, and I'm going to count, even though I numbered those. But really, the way I tied it, it's starting at 1. So I have 1 radius from here to here. Do y'all see that? 2, 3. I really wish this were tighter, but that's okay. 4, 5, and do y'all see that? There's 6 and a little bit is what I have. So this around the outside, this is 6 plus a little radiuses. Okay, and now I want to mark those on my, also on this sheet so I can make some kind of like more standard pictures. But so I'm going to take this can and this with the radius ruler wrapped around it. And like down here at the bottom, here's what I'm going to do. Like right here where there's a 2, and you might tape this in place. I think I used to do that. So like tape it in place so it's not kind of like sliding around like this. So if you have some tape, let's do that. Okay, here I am. I have some tape, and I'm going to tape this in place so that it doesn't slide around anymore. So I can make these things, markings. So I have that. I might put, this is where you see there's going to be slack in here. Right there. I wish it was tighter. I'll just tape it a little tighter, and that will make me feel better about this. Okay. Okay, right in there. Okay, and then I'm going to mark where these radians or radiuses are on this sheet. And I'm going to maybe mark in another color because I already have these diameters and everything in there. So let me see. I think I have a green pencil. And so I'm going to come down everywhere there's a little marking here on my ruler. I'm just going to mark it on my circle. So I'm going to line it up again. Make sure I'm kind of in the center. And then I'm just going to mark them. Nice. Let me find this other one. Here's one. Here's one. And I gotta go back to the beginning. Where's that other one? I know there's one in here. Like there. Okay. So I have these green. Can y'all see these in green? These other markings. And then I'm going to draw using my, hopefully you can see, using my ruler from the center, just not all the way across, but just out. So just radiuses. So a bunch of more green radiuses. So there's one right there. Here's another one. There's another one. Okay. And then I think I'm going to erase these original pencil marks that aren't green so that you can see this picture. So it should kind of look like a bicycle wheel with some spokes that are mostly evenly distributed, but some might not. There's that one extra little one. So you kind of see this spokey wheel. It's not perfect, but this is what we have. And so what happens is, so I want to be clear, I did have, like, each one of these is a radius, right? So from the distance from the circle to the center is what we call r, the radius, right? And with my radius ruler, what happens is I have taken that distance and just figured out how far it took me here. So now this distance between each one of these, because I used my radius ruler, is also r. So that distance is r. Here's another one. Here's another one. Here's another one. Here's another one. This is my little extra. That's not r. I think we can all see that. This is also r. Right? And so it turns out, I'm going to count. There's one, if I start here, like to the left of this extra. 1, 2, 3, 4, 5, 6, and a little bit. So 6 plus a little bit. That's how far it took me to get around this circle. And it turns out if you do this a whole bunch of times, which with a whole bunch of different circles using the radius of those different circles, it's always around 6 and a little bit. And 6 and a little bit is like the exact same thing. If you do this exactly, you'll get 2 pi, because pi is 3.14, and so 2 pi is around 6.28. So every single circle will have 6 and a little bit of these radius kind of sections to it. So if you got less than 6, maybe you look and you're like, oh, there's definitely one section that looks bigger or smaller or is off. But so if we do this kind of with a computer and better measurements, I always get 6 and a little bit. So the formula for circumference, this 2 pi r, is just that I have this r is like I'm using a radius ruler, and honestly there were 6.28 of these when I went around. Like, it's just a counting problem. 1, 2, 3, 4, 5, 6. 6 and a little bit. And in general, I can get like, we'll talk about that in a second. But so like this is the circumference formula, right? So it's just a natural relationship. It's not something that I have to figure out. It's just that for every single circle, the circumference is related to the radius with this relationship for every single circle. Okay. And so because that's true, to measure angles using this natural measurement, right? This is why we give pi a special name out of this geometry. We call this the angle that creates kind of an arc of length r. We call this 1 radian. So this is also 1 radian. This is 1 radian. This is 1 radian. This is 1 radian. This is 1 radian. And if all those are 6, so this would be like the little extra point, like 0.28 whatever radians, right? Because those are my 6 radians, and then I have 0.28. So this angle measure is really like how many times, like how long, this angle measure is really related to like how long this arc is, but just in this other unit of measure. So we call it 1 radian because it creates an arc of length 1 radius. So like here, there's kind of like very similar, but they're very, very connected. But one of them, the radius, we use to measure a distance, and the radian we use to measure an angle. So those are kind of the two differences between them. But if I know that the angle is 2 radians, then I know that this length is also 2r. Like, it's not, they're just really connected like that, right? So here, from here to here, that angle is 2 radians. And so I know the length from here, like if I'm walking around this circle, I know that I have to walk 2 times r, whatever r is. So if r is, like in this case, 5.1, I know that distance is 10.2. But if r is 12 miles, then I know this distance, 2r, is 24 miles. Okay, so that is what a radian is. And also how we measure circumference. Like, circumference is just a count.